doing, we have this coil, and when we energize this coil, let's say we put energy into this coil, we'll just call it E, which is potential. We're going to put energy into this coil, and this coil is going to do this. It's going to charge, and it's going to move its magnetic field down just like this, where this is the North Pole and this is the South Pole. It's going to compress it. Okay, so now if we actually look at this coil, we've compressed this. We're in impulses, so we're compressing this real fast. It's moving down in layers.
How do you know it's moving down in layers,
Well,
John?
because of the energy output of the coil.
Okay.
Okay, we know that we're putting it in, it's just dead solid. It's like a permanent magnet. But this is an electromagnet. So with an electromagnet, we can turn the energy off and on, gating negative energy or vacuum energy. This one is stationary. Once charged, this neutral zone, or what they call the blotch wall, is actually the input of all the energy.
It's BLOCH?
Yes.
Yeah.
So let's get this in an expanded view so you can see this. Then we'll go back to the coil and show you how this energy is going to become an energy pump. With a stationary magnet, once you charge this magnet, the North Pole stays here and the South Pole stays here. But what people don't understand is this is the zero portion of the magnet. There's nothing there. It's the absence of all gravity and everything. So that means the gravitational energy of the magnet is off over here somewhere. All right, so what's happening is once we charge this magnet, the particles align, the oscillation stays, and what we get is two cones. And the energy enters in this way on each side. That's the vacuum energy. So in a permanent magnet, you have a real free energy machine, because this is good for your life. It stays stationary. But it doesn't buy us anything, because we don't have a mechanism right at this point in time to tap this input from both directions. This is the energy of the universe entering this magnet, because it stays permanent. It stays in a perpetual state of magnetism. So it is a free energy machine that's sticking to your refrigerator. Now, let's go back to the coil. What we want to do is create an energy pump to draw the vacuum in. So we applied impulse technology, which are these high voltage potentials, to the coil. The coil pulls in. When we shut this off, this portion that's been compressed, which is now at this level, we're going to leave this out here so you can see this. It's at this level when it's compressed. Now we let the energy loose. And this window starts to move this cone upward for more input energy, and that's where the high voltage comes from. It comes, let's redraw this a little bit so you can get a better idea of how this is going to work. This is our coil symbol. This is an electromagnet because we have some iron here. So when we put the potential across this becomes the North Pole and this becomes the South Pole. And you look at it as a normal electromagnet. However, What we want to create is a vacuum energy pump. So we have to add the impulses. Then we look at the coil like this, and we have these different levels. So here's what's going to happen. We charge the coil, and we get a blotch wall. So we can look at the energy coming in a narrow beam right now. We have to be able to release this so that we can ask the vacuum to pour in energy, because right now it's just stationary as if it was a permanent magnet. So when the transistor lets loose in the monopole motor, it moves upward, the coil starts to collapse. When the coil starts to collapse, notice the vacuum window starts to increase. It's up here, the vacuum window increases to here, increases to here, increases to here, until it goes to 0. Then we add the next impulse, and this comes back down, compresses again. So it compresses and expands, compresses, expands, compresses, expands. And each time you do this, what happens is the output from this coil is the thing that burns out your circuits, which is this very high potential that wasn't there in the beginning. This is the vacuum energy. The normal signal is an impulse trigger. That's how the normal signal would look. It's like a little square wave. This would be 0 volts, this would be 12 volts. So the real back EMF is always going to be far less because of the resistance of the coil. So it's going to want to shoot like this. Shoot downward because it reverses, right? But when you add the impulse technology to it, what happens is you get this tremendous vacuum energy spike that appears on this. And these are in 300 to 500 volt ranges. Okay, and it's always negative. It's charging the battery in an inverted circuit on this machine. So what we want to steal is this right here. And I call it stealing. This is your free energy right here. Also the mechanical energy. So here you are running your motor for this amount of energy, never adding any more energy to the system. The back EMF, everybody likes to term this back EMF because they say, well, the coil reverses, that's the back EMF. That's very untrue. The back EMF is always below the input voltage. So the back EMF here may just be 8 volts. That's not enough to charge your storage battery or to do anything with. So there's always a loss here. This is your loss range. So you try to increase this to get more, and the current just starts to rise. The minute the current catches up in the system, you lose all your vacuum input. So you have ranges that you can bring the current to on the monopole until you just can't get anything out of it. So basically that's what I wanted to explain about the monopole motor, that it's quite capable of doing Tesla's impulse technology. And I can show you a real back EMF return on one of these window motors in a little bit, and you can see that you can't charge the battery with it. You don't get anything. So you need this high potential, way beyond the battery voltage. And you take this potential and you convert it and you send it to the next battery. And it's just a signal to the next battery If you look at the two plates in the battery, and we'll just call these big basketballs ions, what we want to do is potentialize these ions. So we want to put a potential around this ion because we want the ion to move to the next plate for nothing. We don't want to add any current. We want this stuff, we want these ions to all go towards this plate in a recharged fashion. That way it hasn't cost us very much to move these ions. We didn't have to use a big current to move them to the next plate. Now, is there any energy in the battery after using the impulse technology? Okay.